person is healthy or not in, like that. For that required the data. And data regarding different aspects, we can really particular what we can disease. So nowadays we can use smart watches, which will help you to detect our day-to-day activity or day-to-day activities. Okay. Now imagine using your smartwatch. Whatever the body's operations, we can collect that data. Okay. Store it on the cloud. And depending on previous users, whatever their data is and whatever their output, we can predict something about ourselves. That is the basic use of smart device. Your fitness band you can use. Okay. So nowadays use the blood sugar measure machines that calculate body generate blood sugar, which continuously alarming when the blood sugar hits a particular point, it will message your device that blood sugar is increased, do something. Okay. Such type of applications that you can build using your ML code. Okay. Second thing is using your smartwatch, you can monitor your heartbeat rate. Okay. Now depending on your patterns, you can predict when your heart is going to put some additional data, like it will be in a stress, or it will reduce your stress, it will be relaxed, it will produce higher bump, that means your heart is letting high speed, which affect your high blood pressure, and at the end can say that we will be cardiac arrest. It will be cardiac arrest or not. Okay. So if depending on your monitoring your heartbeat rate, if the pattern is predict you are going to be a heart attack, you are getting a heart attack, then they can do something. Prior heart rate going to like some particular point, they can do something so that they avoid the unthinking. Right. So what can we do is we can see right simple problem here. Actually, I am going to explain the monitoring that heart size, but I didn't get proper data with them. So we are not going to do that. But what can we do is based on your data that are available on the channel, we download their data and perform some operation on that data. Okay. For doing any type of analysis, you have certain steps for. Steps like first of all, we need to think of problems. What type of problem we are going to face? What type of solution? What type of problem we are going to tackle? We need to first find out that thing. Second thing is we must know what type of data we are getting, like data content. According to data which parameters what given parameters, depending on parameters, so that we can perform proper diagnosis. Then basically have data in form of Excel sheet right now, but you can connect to the cloud and take the input from the cloud also. Okay. But for doing the technicals, whatever we have in the Excel sheet, we say updating the Excel sheet of the and all the operations. Second thing is after we got the data, we need to export the data. Like it's properly in the container field or not. Because whatever data it takes not accurate all the times. But in medical fields we cannot change any data because it may have something else. Okay. So whatever data is there cannot change their data, but in other applications like industrial applications, you can reduce volume, you can the zero values, particular data is missing, like whatever you see in the data cleaning part. So what can data cleaning is reduce whatever there is missing data, you put the zero. If there is no data, you can remove column. But that not the healthcare data. Because if the data is missing, that means it has something additional reading to it. Okay. So we can directly read the data so that we can find that value and put that data into that particular. That is your data exploration. First, we know the data, how the data is maintained, which column is corresponding to which column is used to which column. Then we can choose a particular and split the data into two parts. Train data and test data. Train data which help you to train a model, and test data will help you to test our model on that particular data. So what can we do in the particular space? We have a data set for that, and we have a target field. Target field is particular output which use out like yes or no, healthy or not healthy, like that. So in one field we data set we take all the data, removing your target field and another field only the target field. Okay. Then we will perform operations on the next field, all the data fields, and predict your Wi-Fi target, and then check Wi-Fi with your original data. To test whether the data accuracy is correct. That is the second part. Then use the scikit libraries for featuring scaling. After that, the model selections. It's very important step. All the process of selecting proper model. Will you use the particular activities? Depending on what data is there to choose a particular model. So here in today's session we use logistic regression model, basic model that will saves data is in the model. After choosing the model, we will train the model with the splitting that we already in our data set. Then test the model with the particular data we have. Particularly we use 80-20 ratio. 80% is for train the model and 20% is for test the model. Finally, practice results which help you to understand, depending on our test result, whether we get how many correction, how many correct results we can get using the conclusion. And lastly, we can conclude something by putting additional task. Okay. So let's do that part first. So this is my data right now. Which particularly contains this field like age, sex, CP, years, cholesterol, FPS, and all this field. Okay. And this is your target field, which contains only 1 and 0. Zero indicate the person is healthy. It doesn't have heart disease. And one indicates person is not healthy, has some heart disease. Okay. This data is available at the you can download it, you can do the particular things. So first thing, as we discussed, we need to import a library file. So we will import this particular libraries. Libraries. First one is Panda, NumPy, then scalar for selecting split library. And from scalar here model, we will implement the logistics model. And scalar analysis we use particular accuracy model from this scalar to find what accuracy, what accuracy that model is produced. Okay. Second thing is now we load our Excel sheet into the computer for which we use panda functions, read file, and path of the file. So now data is appear in my computer in the variable this df is for data frame. Okay. Then we get the different functions. What data is there? Like we can use df function, which will give you the top few records about your data. Particularly say what data is there. Similarly, we can use take function, particularly used for finding last record into your data sets. Similarly, find out what data information of data, you can use the info function, which will particularly use what data is particular column and whether the column is null or not. Okay. This particular is very helpful to find out what data is required to give the model for performing our actual task. Okay. In this shape module, which particularly view how many rows are there, and columns are there. So this data will contain 0 rows and 14 columns. Okay. Describe is a similar info functionality, but more describe your data than the particular field. Okay. Like particular field is a measure value or info field. One is a measure character like that. target is very important for particularly so what will be the final of okay that target field. So we can change this target function like how many trees are there for data present like in the target field we have one is 5 times 0 is 3 1.8 times. Then once verification now we have any artifices and once certification we have artifices. Now we do the target from the data field for your next operations. Okay. For that we use the drop function. You can print the value of 6. You check target is not there in the variable. Similar can have the target into our next axis. Like here 0 records there. Into my value. This target is present the data. We speak going to identify target will be identified by variation. So depending on the input target, we are going to get a variation. Data is organic by hospital. That this particular patient supports depending on these parameters, actually has a higher is the meaning. Okay. And similarly for this particular patient whose age is 70, but though they are trying to get for example it doesn't have any heart. So target will get there is a different field. Going to appear with the previous. Here just data see the data hospital level data we are not meaning into it. It's simply the data tape it makes says that like this particular user entry whose age is 70 and no, it has those level entry. It's like condition. So next is we need to split our data field into your model part. Okay. So what we have next phase is the data field without the target. And why we have target field. Okay, why? So in x-axis we split the data randomly selecting the data into variables. Okay. Then we assign particular value. So this variables here. So x that means contains any model. It contains the data which we are going to use for training our model. one is why test the negative value rows in our data source, which actually going to test our model. Okay, similarly for y test. Okay. And we are saying randomized very starting point very randomly select particular for training and testing. So it takes our data into two particular portions. Okay. That is why you can actually check the shape of data. 80% strain है, 80% strain है, क्या नहीं है. So first thing is we are going to test the data, train the data. So you can say that 61 rows are there, testing our model. 42 rows are there for our training. We are 42 rows for training our model and training our model, 61 rows for testing our model. Next thing is selecting a model. So for selection, we are using the logical regression model. Is present into your package scalar already imported. And we are going to fit the model with our train data. Okay. First thing is we select the model. Right now we are using the logical regression solution for selecting the model. Testing data. Okay. A data train our model. Okay. Now we can predict the data for our testing data. So 20% rows are 20% त्याच्यावर मॉडेलला ट्रेन केले आता टेस्ट डेटा. And then we can train the white. So in particular we use this type of record, first record and 0 and 1. Right now we can now find anything out, find the accuracy about now. This now RAB gate is the output of our model. Now we need to check whether the model gives output is what there is in the actual model. Actual data to find the accuracy, we use the accuracy score method. Which will frame my test into wire grading. So this wire test particularly contains that 20% data, then already present in our data set, and what our model is used is presented in a wire grading. So now depending on these results, you can say that logical regression used with the 85% of accuracy. That means 85% times it gives me the correct result whether the patient is dead or not. So you can say that in healthcare, this is what we can say accessible accuracy. It is not 100% correct. You cannot neglect it. It's just acceptable accuracy here, 85%. Now we can give our own input into our body to check whether that particular data percentage is in or not. Like I use these particular parameters. I give these parameters for a particular person for which I need to predict whether it is healthy or not. Okay. For that I use this has some values of your cholesterol and heart rate, weights, and pulse data. Okay. You can say that this data is came from your smartphone or in your fitness band and stage. Okay. Now I need to pass this data for my prediction. Prediction to my model. So I use model predict function, passing my actual array, which contains my input data. Okay, and I need to reshape it into that manual word manual. Now, depending on this predict output, I can predict whether the percentage is or not. So you can check the predictions. Like it's giving me the zero value, that means percentage is. Okay. Depending on the model. You can customize this output by using some predictions. Like if the prediction is 0, then the percentage is D, prediction is 1, then percentage is not. So whatever prediction is there, they are saying percentage is there. Yeah, there are several models that you can use. That you need to find. That means I am just implementing one particular model, which gives me say 85% of accuracy. Now there are different models like random forest model, or you can say linear regression model, which may give you the different accuracy. Sometimes accuracy will be dropped, sometimes accuracy will be increased. But it's up to a particular data scientist to implement a particular model to check whether the accuracy is whatever the accuracy is. Okay. Then depending on the output of accuracy, you can say that this accuracy is best for this particular type of data. So you can use this. But normally we have some type of what you can say, pre-assumptions. Like this type of data is there, and this particular model will give you the best accuracy. So now this totally depends on my own perspective. So you can say that it might be correct, it might not be correct. But it's just a rough understanding for that. So if my data is, if I only want to predict the values, like price and temperature, is going to implement or not, then I can use the regression model. If I am going to use the spam or spam type of data, or these are no diseases, then I can use the classification model. Like in unsupervised learning, I have no labels, only inputs are there, then I can use the PC. Or just one segmentation, clustering type of model that I can use. So you can say that it just for starting this particular thing. Like if I have this type of data and I want to predict something, depending on what predictions are there, I can use this particular. Okay. And then obviously I can model different model of the same data, use the different type of programming, SQL, libraries. Okay. So find out or I can my own logic perform this clustering or that part. Many of the time it's the data from the industry. We are not type of model we are going to implement. Sometimes first attempt with the 100 accuracy and like 90%. In some model first attempt only 40% accuracy. Then you have showed that if the 30% accuracy you are not going to implement that. Though in first attempt to the accuracy of 85, 90%. You are not next model will be what we are going to implement this accuracy or decrease the accuracy. Unless and try that we are not sure. So we need to try that. Okay. But what you can from this starting from beginning a particular project, what type of model that you choose for that guidelines I can use this particular. We have a large amount of data. In that case, CNN is the CNN. Okay. Where we need to find the complex pattern is identifying the image, the image, or a particular pattern into the indicate the CN. Where we can perform several tasks at the same time. Okay. Right now, I am working on the project which is particularly trying to produce a transcript for Modi language. That means whatever the documents are there into Modi, we are going to translate that Modi script into another language like Marathi or English. For that, we have image type of data. From that image, we need to identify a particular character and then translate that character. For that type of project, we are using the CNN. So using CNN, we can perform the same. First thing is, we can separate out one particular portion, recognize a particular pattern, then identify that pattern for different character sets, and then produce the output of that particular pattern. Now to implement the CNN model for this particular project, we have different models. One model in CNN also contains different types of models. So one model is will give me a 70% accuracy, one model will give me 80% accuracy, one model will give me a 75% accuracy. Now it's my task to choose a particular model for finalizing my project. So if my project doesn't give me the 100% accuracy, you can say that there is always be another model available which give me the higher accuracy than my model. Okay. So if you want to get sure that your model is the final model, it will not be overcome by some another model, then you need to make sure that accuracy that you produce into your model is the particular limit. Above that limit, there will be any model available that gives you more accuracy. That's the only thing. Okay. So this is the particular model for your heart disease detection. Similarly, you can use this cancer prediction model also. That will particularly test for breast cancer. For breast cancer, you can say that if there is some clot is there, identified depending on that clot's properties, you can say that this particular clot is for breast cancer or not, endometrial cancer or not. Cancer ची गाठ आहे तर दुसरी कोणती गाठ. त्यासाठी पण मॉडेल आहे. त्यासाठी आपण इथं रँडम फॉरेस्ट क्लासिफायर यूज केलेले आहे. इंस्टेड ऑफ यूजिंग युअर लिनियर इक्वेशन, we implement the random forest model. Okay. So program is here. You can say that. Accuracy of this particular program is 70%. Basically, what I am trying to say is, machine learning is not hard. You just need to do the same thing again and again with the help of different models. only identify some data set first, identify what is your data set, which the baseline accuracy, and implement that. Once the model is implemented, you can get the dashboard. You can create different apps to display your dashboard data, and then you can send that into a model. So I can say that what model we have already prepared for industry. So among them, one model is boilers, accuracy kind of. How we can change the model. What that we change the data of the industry, what the tasks, produce the model, and how they are there. We prepare a dashboard and send the dashboard into the industry. Now industry is going to use that dashboard for whatever the data they are for the boiler and perform upon this. Whether we close the boiler or what fuel efficiency is like that. What type of time will be taken, what type of time will be taken, it also shows you when the boiler rate fail. If the particular average is very high, with going to fail. So you can stop the boiler. Any questions? Yes.
For accuracy, do you have any standards regarding any for this person is here or not? From what standard you can say after this reading person is here, your person do you have any standards?
But there are what that implemented by the model that getting more accurate. What that implemented different.
So do you have any standard for that?
No.
This is standard. No,
there is substance like 99% if the accuracy is 99% this is 1% my reading. So for here this 1% chance can also be assumed. So you cannot make the data is. So there might be a certainty. You can say that 85% of time my model will be predict correctly. That's a direct accuracy.
Hello, Mr. Edwards.
जेव्हा हा प्रोजेक्ट सुरू करायचा होता ना लेक्चर द्यायचं होतं त्यावेळेस सरांनी डिसाईड केलं होतं की आपण ECG वरचा प्रोजेक्ट त्याचा अनालिसिस करून पण ECG वरचा डेटा आम्हाला कलेक्ट करता आला. ऍक्च्युली रेडिओलॉजीचं लेक्चर झालं, त्याच्यानंतर असं होतं की त्या रेडिओलॉजी बेसवरच आपण प्रोजेक्ट कंप्लीट करायचा. सो वी हॅव अ टीम which are performing this task, right, in the university. What we need is more persons than for doing this task. म्हणजे ECG वरचा analysis करायचे. ECG वरचा analysis कसं करता येईल आता? ECG चा different types of wave pattern आपल्याकडे आहे available. तो डेटा आहे. त्या डेटावरचा आता आपल्याला निरीक्षण करायचे की कोणत्या पर्टिक्युलर सेक्शनला त्याला हार्ट रेट वाढला आहे, कोणत्या पर्टिक्युलर सेक्शनला हार्ट रेट कमी झाला आहे, आणि त्याच्यावरून मग हार्टला डायग्नोस करायचे की कार्डियक अरेस्ट नाही येणार, त्याचे काय चान्सेस. मग हा प्रोजेक्ट ऍक्च्युली दाखवायचा पण डेटा कन्स्ट्रेंट, शेअरिंग कन्स्ट्रेंट, वी आर नॉट गोइंग टू शो दॅट पार्ट. And more you can say that त्या फील्डमध्ये आजची एक्सपर्ट एवढी नाही. म्हणजे कोणती मेडिकल फील्ड, ऑब्वियसली आपण इंजिनिअरिंग बॅकग्राऊंड, मेडिकलचा आपल्याला बेअर मिनिमम माहिती. डेटा सगळ्यात महत्त्वाचे की मला नॉलेज आहे का नाही. काही बेसिक नॉलेज असलेलं चालतं. त्यात मोर म्हणजे कसं आहे डेटा वरनं आपण काहीतरी प्रेडिक्ट करतोय. हे प्रेडिक्शन करते आपल्याला नॉलेज असलं तर आपल्याला सांगतोय की हे डेटाचा डेटा आहे, हा प्रॉपर्टी आहे. पण डेटा कधी खोटं बोलत नाही. डेटा जो आहे तो ऑटो येतोय. तो तुम्हाला पेपर्स देतोय. त्याच्यावर नवीन प्रोसेस काय भेटू शकतं. जस्ट लाईक बॉयलरच्या प्रोजेक्टमध्ये बॉयलर माहिती नव्हती, पण आम्ही काय करून दाखवलं डेटाच्यावरनं. इंडस्ट्रीमध्ये लोक म्हणतात ही गोष्ट होऊ शकत नाही, पण जेव्हा ऍक्टिव्हिटी करून पाहिजे तेव्हा त्यांना कळलं की याच्यामध्ये बेसिक नॉलेज असलं तरी आपण नॉलेज असलं तरी आपण जे इम्प्लिमेंट करून पाहिजे त्याची इम्प्लिमेंट करून पाहिजे किंवा आउटपुट आपल्याला काढू शकतो. तसंच काही फील्डमध्ये जर बेसिक नॉलेज नाही करायला त्याला अनालिसिस करायला त्याचे साईड इफेक्ट पण होऊ शकतात. मेडिकलच्या फील्डमध्ये साईड इफेक्ट येण्याचे चान्सेस जास्त, कारण की आपण एखाद्या फील्डला लिंक करतोय, ती फील्ड करतोय आउटलायर्स मेडिकलमध्ये फाइंड आउट करणं, कारण की नॉर्मल फ्लो मध्ये प्रेडिक्ट करते. तो सगळ्यासाठी बरोबर चालतो. सगळ्यात एक आउटलायर असतो, एक आउटलायर त्या पर्टिक्युलर मॉडेल सोबत मॅच होतो. त्या केसमध्ये त्या आउटलायर केस असेल कोणता फॅक्टर पेशंट सर्व्हाइव्ह करायला आहे. फॉर एक्झाम्पल म्हणायचं तर आपण कॅन्सर डिटेक्शन मध्ये एक पर्टिक्युलर केस कॅन्सर प्री-अपीयर होण्यासाठी आपण काय पॅरामीटर्स लावले की कॅन्सर प्री-अपीयर होऊ शकतो. हा डेटा प्रेडिक्ट करून सांगतो. आणि डेटा प्रेडिक्शन्स म्हणजे यात कसा आउटलायर असते की त्याला आउटलायर असं डेटा त्याला सांगतोय आउटलायर तो बरोबर आहे. दुसऱ्या पेशंटला आलाय पण याला नाही. मग याला काय आलाय हे जर आपण फाइंड आउट करू शकतो. डिपेंडिंग ऑन द डेटा व्हाट वी कॅन गेट टू फाइंड आउट व्हाट द सोल्युशन ऑन दॅट पर्टिक्युलर कॅन्सर. प्री-अपीयरिंगचे चान्सेस आहे तुमच्या याच्यावर डेली हॅबिट्स कशा आहेत.
Start to cure. Again, that I have observed. In that case, thinking of the model, in that case, we will be supposed to give the information of occurrence of cancer.
What if right now? for all the patients use the model will give you the काही डेटा घेतला तेच सांगतोय माझं मॉडेल तेच सांगतोय की पेशंटला कॅन्सर होऊ शकतो येणारच म्हणणार नाही तो असं कधीच म्हणणार नाही मला ॲपेरिंगचे चान्सेस नाही ते फॅक्टर्स फाइंड आउट करण्यासाठी जास्त डेटा जो डेटा आपण कॅप्चर करतोय क्लिअर आणि क्लिअर किंवा डेटा आहे त्याच्यामध्ये डेटा एंट्री करणारा पण तेवढा काही हे नाही डेटा एंट्री करणारा असतो विभागाचा फाईल बदलतो त्याच्या टायपिंग मिस्टेकमुळे आपला प्रोडक्ट आपण त्याच्यात चेंजेस त्याच्यासाठी काय करायला पाहिजे डॉक्टर असतो त्याला डेटा एंट्रीचा टास्क तो प्रॉपरली डेटा फिल करतो पण डॉक्टरच आपल्याकडे सोडूनचा डेटा एंट्री करायला डॉक्टर पण रेडी होणार नाही तो पण तसा डेटा करणार याचं सोल्युशन काय आपल्याला आपण एका मेंटल पाहिजे फाइंड आउट करावा आणि रिगरस डेटा आपल्याला जेवढा जास्त भेटेल तेवढाच एनालिसिस दुसऱ्या केसेसमध्ये कमी डेटावरनं पण क्रेडिट पाहिजे मोर ऑर लेस हेल्थ केअर मध्ये जेवढा जास्त डेटा थोडी आमची ऍक्युरेसी जास्त होण्याचे चान्सेस म्हणून एकतर आपल्याला रिगरस डेटा पाहिजे दुसरा आपल्याला लार्ज डेटा जेवढा जास्त डेटा असेल तेवढे जास्त आपल्याला करता येईल या पॅटर्नवरून आपण प्रिडिक्ट करू शकतो आमचा एक प्रोजेक्ट होता आपल्या मोबिऑल सोबत त्याच्यामध्ये आम्ही कॅन्सर्स डिटेक्ट करत होतो कोण कॅन्सर्स पर्टिक्युलर परत हेल्थ केअर मध्ये मशीन्स प्रेडिक्शन लॉजिक हे डिबेटेबल आहे काही डॉक्टर्स म्हणतात की ते ऍक्सेप्टेबल आहे का नाही परत ऍक्सेप्ट करायचं का नाही डायरेक्टली पेशंटला दाखवायचं का नाही हे कसं समजायचं हा डिबेटेबल क्वेश्चन आहे याच्यावर काही लोक म्हणतात की एआय ला सपोर्ट करतो काय प्रकारे सपोर्ट करतो पण शेवटी प्रेडिक्ट करणं आणि ते टेस्ट करणं हे डॉक्टरवरच डिपेंड होतं डॉक्टरच सांगू शकतो की याला काय चान्सेस आहेत म्हणजे याला क्युअर करायचं का नाही शेवटी चेक केलं की तो सेकंड असतातच आपण एखाद्या पेशंटला पेशंटला घरी पाठवलं घरी गेल्यावर असं 100% डॉक्टरही सांगू शकतो तसंच डेटा आता काही इन्स्टिट्यूटमध्ये जो मॉडेल होता आम्ही बीओच्या बरोबर बनवतो त्याला कन्व्हिन्स करायचं टेस्ट करू भारतीय मॉडेल कारण आमचा तुमचा डेटा करतोय मतलब आम्ही डेटा दिलाय प्रिडिक्शन काहीतरी आहे तुम्ही चेक करा प्रिडिक्शन चेक नाही त्याचा इंडिकेशन accuracy but data ये 67% 67% is the close है so 80 how more or less accurate 67% म्हणजे थोडं कमीच आहे त्यासाठी आपल्याला डेटा पाहिजे जेवढा जास्त डेटा भेटत असतं मॉडेल होईल जास्त मॉडेल तुम्ही प्रिडिक्ट करायला हेल्प करताय कन्स्ट्रेंट इथे येतात डेटा आपल्याला प्रॉपर येतो आणि डेटामध्ये कॉलेजेस डिस्ट्रिक्ट हॉस्पिटल their data restoration is also some hospitals collect some hospital neglect some particular portion of it like cancer generation मध्ये heart rate BP blood sugar cholesterol level त्यांचे parameters असेल, really हे record याच्यातला record करत मग ज्या तुला सांगायला याच पॅनल एखादा जेणेकरून तो डेटा मॉडेलला आता काही पर्टिक्युलर कोर्स डेटामध्ये चेंज करत नाही. मग तिथं मला
Thank you very much, sir, for the excellent. Thank you very much, sir, for the excellent and your demonstration of demonstration mode of creation in medical ML mode helps us understand how intelligent patient monitoring and healthcare patient monitoring and healthcare. Let us all give a big round of applause. Let us all give a big round of applause. May I Dr. Royal Sandal kindly come forward and take our esteemed resource person for his second session.
आपल्याला 10 मिनिटं वेळ आहे त्याच्यासाठी. त्याच्यामध्ये आपण काय करूया ते सुरू करू. And while going off the meeting, we have put some dialogue. We are upstairs. That place also will come. Okay. I request all our assistants to come over.
I request all the resource persons, participants, faculty members, and students, please come and join us for a program.
JioTag is sir.
काल बरीच होती आज ते आम्हाला कमी आहे पण त्यामुळे फक्त लगेच सांगा सगळे दिसले झालो की आपण काय करू खाली
Please carry your lunch well. Please carry your lunch नीचे एक और group photograph है please ground floor building ground floor break over please carry your lunch along with after ground photography when we go to the D2 first class carry your lunch
अख्खा गरम झालं.
काय बराबर आहे
एक से बसा
Good afternoon, everyone. Good afternoon, everyone. To our third session of second day. Now it is my privilege to invite Dr. Anita Gade personally. Dr. Anita Gade is an academic with a PhD in artificial intelligence. Her research focuses on innovative applications of deep learning in medical work on non-invasive biomarkers using deep biomarkers has been published in several international journals and conventional journals, and she also holds a patent in this domain. Dr. Anita Gade has further extended her postdoctoral fellowship program in electronics and communication engineering at College under the faculty of advanced research reflects her strong innovation in artificial intelligence and currently she is working as a software engineer at the Research and Development Center, Healthcare Innovation Center, advanced AI solutions to advanced AI solutions in medical imaging and healthcare. She has also actively collaborated with several research projects, faculty members contributing meaningful academic and research initiatives. We are proud to share that she is also an alumnus of our own making her visit even more special and inspiring for all of us. I now request Dr. Anita Gade and enlighten us forward and enlighten us with her AI tools on healthcare. AI tools. Let us welcome her with a big round of applause.
Hello, am I audible? First of all, after lunch, good afternoon to all of you. Good afternoon to all of you. Wait for some time. We can start.
You will start taking on. If you not start taking on, I have to put message the session started.
First of all, thank you, madam, for the nice introduction. Little bit tension for me. I am student giving the session in front of tension for me today. Tension I will try my best, but I will try my best.
You have done great works. You have done great works. No need to worry.
So going into the depth, there are something maybe I will explain the things, whatever application based. I think I will instead of going into the algorithm level, how we can use the AI in healthcare. So first of all, I will just from yesterday you are right? Artificial engineering, education, in any area of education. So I will not go into the detail, but leveraging the AI are helpful here. Leveraging the AI is helpful here. So we are mapping digital data, using the clinical data, whatever the condition, society faster, every time we need and automation and operational efficiency, and it's a little bit difficult doctor, make a doctor. So AI is faster. So AI make a go to the doctor and make a decision quicker and make so AI pattern. So AI pattern workflow optimization, workflow optimization. ML models learn from ML models learn from the ML models support the clinical decisions, adoption across the radiology, pathology, these are the current and trends, these are the current and trends in the AI in healthcare. These are the concepts I just go through AI, ML, for here, AI, ML, for AI enables the intelligent task, AI enables the intelligent task and ML processes the data, ML processes the data, we are training data driven which we are using in the machine learning. So machine learning method already knows supervised learning, these are different types of algorithms and techniques, artificial intelligence. Whatever we are developing in the healthcare and adopting the AI in the healthcare, we need the reality. So in the reality, whatever we are implementing, it should be reliability of the product, it should be bias management of effects, we need the validation of this thing. We need the validation of practical healthcare AI, reinforcement learning for ICU management, something we can. I will go for the next. This is the basic AI application. I guess AI application, the data aggregation layer, the data aggregation layer, and put as the data input areas, ECG data, patient data, chronic health, any patient data, independent group, then whatever the data available is sometimes in data, right? Here sometimes data is structured data, so we need the data normalization at the European. So then we have they models, but how different, whatever I mostly use, say transformer, CAN model, validation, cross validation things. Then deployment of the AI model, like you mostly heard about the Amazon Web Services, something, right? So SageMaker, Amazon SageMaker, these things are useful in the deployment of the AI application. So then integration with the clinical system like PACS, nothing but the picture archival, computer communication, then DICOM. These are the standards in the healthcare imaging. Whatever we are deploying the data model in the cloud, that time we need to perform these things. So these are the traditional machine learning models which we can offer in the interpretability and the clinical decision support system. As we have a supervised learning, we don't have the data set we are not training the model. It works on the what we can say as a cluster and the hidden features. Then deep learning in medical imaging. Right now it's more in medical imaging. As I am working in medical imaging, mostly deep learning is useful because whatever the CNN enables the segmentation, classification of the medical images, enhancing the diagnostic across the CT, MRI, X-ray images. Your input may be CT image, X-ray image, or ultrasound, anything. So we are using this. Whatever I have used the LSTM, Blue model, the transformer, GAN. Maybe from yesterday you are hearing about the generative AI something, right? In healthcare, we are mostly facing the challenges of the data because data is the something which are not getting to train the model. So in this we need to generate the data. So generative adversarial network, something generative AI which generates the synthetic data to train our model. It works as a generator and discriminator in both ways. It generates the data signals input whatever we need to train the model, and again it validates the true data, fake data. Something just like given the company, what is the purpose and how we which models we can use where. Suppose LSTM is there, if in ICU sometimes this is a time series data, and I want to work with the time series application. Suppose ICU ECG monitoring something, then I will go for the LSTM. In healthcare, I can't say that any model is ideal because everywhere model is whatever its core model is having a core capability, but it depends upon the use case. For what use cases, what models you are selecting. Suppose for the simple application, if you are using the deep learning, it's not required. Overfitting, underfitting, these types of problems are we need to face it, right? So whatever our problem definition, accordingly we need to select the model which model will perform the best. So these are the in NLP. You heard about the natural language processing and all. I will just give a one example. For whatever right now there are electronic health record. Lot of documents are available, right? So we need LLM. So when I whatever I implemented, I haven't added here, but I will just give a one example. Suppose if I am working for generate reading, I know 3, 6, 7 documents on whatever the data I have. So I want to what I can say that I want to generate that helpful for me. So whatever I tried is that I have used the LLM RAG. RAG is nothing but a retrieval augmented generation. Its text understanding is a better, what I understood. Then BERT is there. These are the different models which we can use for the we can use with the LLM, Llama 3 and something. These types of algorithm we can use the natural language processing. Suppose for example, I will give one example. Suppose when we are going into the CT scan or X-ray, some clinician is pressing some buttons, these things. So right now what industry is trying is that instead of pressing this button, I will use the voice command, and natural language processing will come into the picture and it will automatically perform whatever it will give you the signals to the machine, whatever you need to perform. These things they are developing these things right now. Means NLP is important in the healthcare, which I am trying to say here. So these are the different CT, MRI, ultrasound, X-ray. We can use the AI for a different purpose, basically image reconstruction. Right now, sometimes there are many challenges, right? 2D to 3D reconstruction of the image. So here we are mostly using the deep learning convolutional neural network for the generation of the 2D to 3D reconstruction of the signal, because whatever the radiation doses, you heard about the radiation, right? If you want, radiation is harmful to the patient. So you want to reduce the radiation dose. At that time, you need the better quality of the image. And if you are increasing in the radiation dose, then patient's health is not. It affects the patient. So if I want to reduce the dose, then at that time still for the diagnosis purpose, my image should be clear. And at that time, we need a lot of image work beside that. Because I am reducing the radiation, and at that time my image should get better. We need the AI to build the image which is useful for the diagnosis purpose. This is the one example which I can share here. So one more thing, when we are working with all of these things, again some regulatory standards, maybe you heard about that FDA, software as a service, then something as HIPAA, as Health Insurance Act and Data Privacy Act. These things we need to follow when we are creating when we are deploying any AI application. We need this AI ethical, and these things we need to consider. So right now I think whatever the patents in fields I had, so I will just explain and added here. One thing I think everyone knows the ventilator, right? So in ventilator, what I done is that if you have seen, maybe it should not be the case, someone has seen it, but if you have seen it, it's a ventilator is a life-threatening something, right? When someone is facing a challenges with the life, at that time they are going to the ventilator. So in the ventilator nowadays, there is no any feature of the smart cleaning, which I introduced here I work on it as prototype and I hit the patent and it's published. So smart weaning means nothing but the ventilator you observe the hospital. So what doctor? Yes. So what is the case is that when patient is on the ventilator, at that time we want when patient start. I think I will explain what is weaning first. Weaning is nothing but we are gradually reducing the ventilator support, and to reduce the gradually reducing the ventilator support is a little bit difficult for the doctors also. If I will reduce more pain, sometimes patients will get impacted. These are the lot of challenging things that should be under the observation of the doctor only. But we can make the clinical itself support system for the doctors and clinical is good. So what I have done is that I have implemented an AI algorithm. So whenever patients start their own breathing, it automatically gradually reduces their ventilator support. And it will check and what is the data available, patient history, lot of things. So all of the considering patient's history and how many days in the ventilator and these things. Considering these things, it will automatically, it will suggest the doctor, clinicians, we can reduce the ventilator support for this patient gradually. And this is the, I think, good example. In that way, we can think about how we can leverage the AI in healthcare. That's why I told that I will not go into the algorithm level. If you can search the algorithm on Google, you will get it. But whatever the application we can implement, and as you are the faculty and researcher, I know most of the people. So if we can think in that it's a research, it's a good research which I can think, which I can say. So this is I think good example, and one more thing that what I tried is that
whatever algorithms after the Google, we directly implement
directly implement, we need to understand the algorithm first. Is it really satisfy my problem? We work on that first. It is overfitting. Lot of things are coming into the it will not work most of the time. Some algorithms will not work for your case. That's why you need to study on that algorithm. This coding and these things you will be able to get from the mobile or something. But algorithm selection is a challenging task for us. How as architect level, we need to understand how which algorithms I can select for it. So we need to study on that. How I will get better output. In healthcare, we need the better accuracy. We are not compromising on the accuracy. So no work will publish down the accuracy.
Because in last session what happens? The students told us that algorithms related to healthcare, which are available on the internet.
Right, these are available. Right, these are available. That's why I told you that you can search on the Google, you will get it. But which algorithm you need to use for your application, you need to select that. All the algorithms, codes are available. That's why I am saying that if I will search for the same, it's available. Everything is available on the Google, Copilot, you will get it. But which algorithm is suitable for my application, my use case? We need to understand that. Means if I will try, if I didn't understand something, I will try to use some algorithm, then it will not give the better output. That's
While designing ventilator at your company, how do you decide what are the database that you use?
yeah, this is the means I can Philips has provided me their data. I will not share their data, but Philips have their own data policy and this department is there. So they have, but I have worked on the synthetic data. They are 6 months, but we can generate, that's why I told you that, but we can generate that right now, even why they don't have data. Right now, I don't have data, whatever I have, right? You want to use whatever data, you want to use data, generate generic data, generate, I don't can use data, I don't, generative generative is the synthetic data, generative as synthetic data which works as like the right data. So you can try this.
Which algorithm is what about its accuracy and what about its accuracy and for your case?
I think I will not explain privacy because of but it's a privacy. But so I am not release the product release the product level is not yet released right now. Okay, yes.
Likewise, which algorithm you are taking, what about its consideration, which parameters are taken into consideration for
Yeah, yes. I get you. Yes, you also right of levels, also right SPO levels, as SPO2, four parameters which I consider, the chemical VO2, SPO1, four parameters that I have considered, first I tried that was more than 70%, then I tried some other algorithms, distribution algorithm I tried, distribution algorithm I tried. Right now I am trying to more accuracy, more accuracy. It should be more than 90%. It should be more than 90%. Try and error, right? Then you can switch on the That's why I told you that which I understand the algorithm, which I want to. If this algorithm is not giving me the algorithm data accuracy, then I will see the data accuracy, and I will see that done the same. I tried random first, then I ran the other, then I switch with the other algorithm, the better. No, right now also I had 87%. Right now I'm trying doing the algorithm. I think it will give me the code. Accuracy. So again, I think I will give one more patent which I had medical systems, right? We have systems, right? We have a medical system. We have a medical validate the system. Validate the system. Validation is a critical task. Suppose if I want a laptop, Philips wants to test as a CT scan machine, having more than 1,000 tests. If someone is trying to take a lot of time, product marketing, time. That's why as a process value and customer consider we need to optimize the flow. So whatever I tried is my track, how implemented my track AI, how implemented so AI. Manual going to the first stage, going to the third stage, that takes and they are with the manual. So whatever the cases I guide user you are asking the algorithm, you are asking the algorithm optimize all the my model is doing all the instead of going there at system control to grow by step. The company has profit for that company. In that way we need to think optimize the I think this is the example for optimization. Question I had given feature can advance the thing. In that feature I am doing a new feature. I am not a new feature with any competition right now. That is my contribution, but that is my whatever lot of takes lot of like 8 to 9 months. So again so testing and I want to automate something new using something new technique. So we are to reduce manual. I want time to market reduce. Means instead of tested in one should be the when we are launching the API in the market, we need that's why model track is the best for track is the best and the work LLM and work in the text understanding, what is understanding, what is also I implemented here, what is I got the good with the accuracy, track and word model. These are the one more section which I will tell you. What I had done is laboratory in so each already. So patient having diabetes, every the blood they are treating the blood, treating the blood and diabetes is very common. Rural area people also the diabetes. So it should be my solution should be the very useful for the everyone. It should not be everyone. Like from what I had done that taking the taking the insulin. So instead of doing this blood, I if we can capture the pitch, then we get the picture, they get the divergent condition, and all of these type of data control type of process which is PhD guide, and so and he texted our supervisor. So I think it was working nice. I think it was working nice that part of going that with the bread, going all of the bread filling and all, and they also use the different, AUs. I have tried different. Try the trick first. I didn't get more accuracy. I didn't get more accuracy. I tried got a third approach. I got third better accuracy as a 94. So I think in that way we can, which I can suggest is that in that way we can just think that how we can leverage how we can leverage some in the healthcare as a picture layer something how we can optimize something how we can add some features profitable for that researcher we are contributing the group.
I will handle this kind of activity. It is about the electronics hardware
Okay, hardware related. Working on this where you can ask me the detection. I use the sensor detection. I use the sensors. 7 sensors because they are capturing signals and we are working on signals and we are working on the sensors. Yes. Micro correct. There are lot of micro correct. There are lot of signals are right. That's why I am not right. That's why I am not capturing and noise and signaling and that's why I am not capturing. That's why I am not capturing. I had the combination of the 6 sensors. I combination of the 6 sensors. Then I had the merging of this output of merging the then I tried because then higher resistors a lot of like a lot of noise and we need the 50 like whatever standard process we need to as the data processing normally as the data processing normally we need to work everything. So I think right now just I think in the case the AI and the different as a infection in the ICU, the infection emergencies and the infection diseases and infection finding infection and this thing particular daytime. So whatever fighters daytime labs with operations that fire and this is lab monitoring and blood test and this is we are again patient health record all this again patient health record and then we are running as in and then we are here 5 am suggested that here 5 am suggested that here is the time so you can try that so you can try that results like that so real time clinical integration that real time clinical integration with whatever data out of the clinical decision support system we need clinical decision support system we need these are the things the case study are the things in the case study of the ICU. This is the example for the imaging for the detailed imaging I can say that case study I can say that how CT image right everyone so whatever the so time over the CT we are getting the radiation is a not we want to optimize that so we want to optimize that to the image quality the image quality and we give the image vector algorithm and there we vector algorithm and here we are introducing the data to get the vector. So just like one example, how we can detect the cancer detect the cities. So just as a part processing now and images processing in classification CNN so they transfer train the model then they are deploying the model. So okay, taking actually CT scan is my right. So when the process is gestation is providing solution of the level. It can consist of hundred of slides presentation of the level. The level is not the only the data which I have is a lot of pages. Simply processing we have to check right. So it removes the unnecessary structures. There are these pages when they are then the search the right. So we want to remove that and we want to focus if we are working on the learning prediction, we need to focus that right. So that's why we are removing this release heard and issue from the events. So they are the normalization, they are normalization, the intended as we are there. They reexamining this can compare the different outside sometimes compare so we need to do this setting of the image. So five pieces of 3D image that the 3D image is the data of the image, right? Whatever the data, so we are on the 3D image. So we are not of the channel the patient working with the learning. These are the visualization that the location is considered part of the image. One walks around the fair that part in the detection of identity. We can consider. So there is sometimes chance of distributed conditions are so we get to remember together and identity who we are and analyzing individually are right. Can not monitor for like some data. This is called in my algorithm or whatever first is the photo. We are taking the human humor as some all and after identifying the real nodal determine that the nodal is a cancer of some other nodal right. So we can't say that we can answer. So again we need to check. They are transfer the image characteristics including irregular borders, classification, classification, total size, density, growth factors. We have detected some tumor conditions. Then we are again validating this parameter. This is really cancer or not. So then model operates the probability score indicating how likely the model is to be cancerous. This percentage, how it can predict, just like I said that. Radiologists will do that these things, but just model will predict that how much the chances of the cancer something. Okay. As I just explained there how vision transfer I use here. Just vision transfer we just like working into the patches. We divide the image into the patches. Vision transfer is like I have to suppose to 51 to 51 image. And if I want to divide it to 16, then again we need to do the calculation, and these times these patches will generate. And again each patch will what I can say that calculate obviously each patch is relevant to other patches. Means if we check all the it analyzes all the patches with each other. Then we check is it really whatever I have, is it really cancerous or not? So in some systems, segmentation is performed to obtain the exact boundary of the tumor, right? So purpose of the segmentation, I think you already know about it. Precise the tumor boundaries, tumor volume measurement, and the number of time. This information monitoring the disease localization. So radiologist again, whatever we have detected again, we need the clinical opinion on that. Radiologist opinion is the final opinion. We are just assessing whatever processes are there to the model. play one video. I don't know if you know. Maybe I think this slide, maybe you can go through it, try. I don't know. Very good. Just look into it. Explain maybe what.
Speaker screen correct.
Here just explain that how AI is helping to the reading for the analysis. So at the start they show the two images, right? And both images they whatever the at the last maybe you were to see that two images, whatever the learner can answer, he predict at last they show whatever the learner can answer, they show the now upgraded the image with the input image to the output image. Each image editor needs to think about 10 to 15 images. If we can provide them as a decision support, they will not take more time than that. If we are using external AI suggest this what I can say that the percentage level whatever the output they should explain why I have predicted. They should be paid for the to understand how AI is predicted. Maybe I will share the slides with you. You can see later also. It's not the problem. It's not working. Another example for the AI concept of breast cancer detection. So, personally, the cancer detection is the breast cancer detection. Whatever the model AI, we can now using the lung cancer detection. So, every skin model combine the object and classification for analysis and key images. We are working on the images, how identify pattern in the cancer, lung cancer, what are the images we have captured. Radiologist is the same design. Studying that image, that one is able, right? Is the cancer is patient. Now, model is helping model is just predict the whatever the conditions of the patient. So,
माइक चालू चालू
okay, I slide, then I think you can go on it if you want to check.
शिक्षण काढून लॅपटॉपला आवाज येतो का बघा. हा व्हिडिओ प्ले केलं की नाही आपल्याला माहिती येत नाही ऑडिओ नाही.
We can play with the video game. I will take. At last, I think we can try with the video. Right now, we can play. So basically, whatever the cancer detection, breast cancer detection, whatever they are in the we have hidden AI, identified small portion of the lung cancer detection, breast cancer detection. Use the AI model, the patient is the blood cancer, breast cancer. With the same images, we can play with the. So, what is the main purpose? The radiation. So, reduce the radiation. So, whatever the radiologist is doing, but also the radiation is get those radiation is get those getting to the patient. The radiation is get those radiation is get those getting to the patient. Back to patient. Our patient those increase the image quality. Increase the image quality. Work with the AI. Get the expected out. Then I think this is the another case. In the AI enhanced. So I think the CT scan, MRI. Suppose I want MRI will work pain tumor something. So we are doing the soft tissue. I think first we are going the MRI machines. So these are the MR challenges that MRI we are not radiation, not magnetic resonance, and we can say that basically we are using. So MRI images artifacts caused by maybe your patient is a child, they are not stable, right? They are just stable, right? They are just because it takes a lot of time, as a old year also get stable, whatever capture, you want to capture, get stable. So we are not stable emotions that the image will impact the image. Overcome this, we need to do something in the images, right? Something in the images, right? Whatever the missing parts in the images, that's AI. So whatever the images I captured from the MRI machines, maybe sometimes we are not stable, that's why some images are not, and something babies are not stable, we are also, and in that case, we can wait for the AI model, generate the image with the missing file, and with the better quality of sometimes we are not stable, clarity of the image, and also we are introducing the AI more clear processing of the next part, and the diagnosis purpose. So this is the brain. MRI scan the sample here. MRI scan time, which I told, right? Patient is not able for 45 minutes. So there is some missing information because they are done the motions and everything, right? So we need we have noisy the clear image, remove the noise and the we need to work on it. manufactured in the input image. So they super resolution of image, spatial resolution. Then as a six, we need to do the segmentation. The suspicious label we are detecting, the principle we are detecting. So and last everywhere opinion of the radiologist is the brain everywhere. The case data, we are doing for the reconstruction of the image, for the reconstruction of the image, then we are the convolution neural net for the net, then aspect correction, CNN supervision of the net, supernet segmentation, the unit segmentation, of smart. Whatever we have image in the higher, we are doing the information, then CNN, because then CNN extract the features, and CNN predicts the missing, combine the reconstructed finer, then generate the finer quality, then the reconstructed, then out which we will get the reconstruction of the radiologist, give the radiologist, whatever we are expecting, whatever